Welcome back to the episode 4, session 2, GAN development in progress. Let's try to understand some practical usage on this Torch module. Now again, you can see now we already have these code lines in our main.py program. So we are trying to see practical, some applications, a little bit very basic practical calculations on this Torch module. So we can see a little bit of coding is there using Torch module directly. Import Torch. Let's right away do this and see. I'm going to use this one and go to here. Let me clear this one, and we can say Py, the main prompt, and I can right away say import Torch. Okay, then I'm trying to use this one. X random like this. So what it does, as it says, create random tensor of size 3 into 3. Tensor. We don't know what is a tensor yet. Let's try to understand what is a tensor is. No errors. We are using the syntax correctly. And let's continue this coding with explanation. And again, another variable is defined and a value is assigned like this. The value, what is the value? Is telling torch sum x. So what is the value of x? Value of x is randomly generated tensor. We can say two-dimensional array 3 into 3, and it is assigned just a set of random values with a two-dimensional array. It is assigned to x. Then the values within that tensor, I don't want to use the word array for tensor because there are differences. Because arrays we know with the indexing and all, most of the programming languages are having arrays. But why in AI programming, we can say Python programming, machine learning, why they use a word called tensor? Because there's a difference between arrays and tensors. So let's try to understand what is a tensor, but till we understand, I might use arrays several times, right? Because that's the most familiar word to us. Some of these contents in the tensor is taken and assigned to another variable called y, and then what we're trying to do here, printing the value of sum is printed. So that is what's going to happen in this program, small program. Let's try to enter here. Let me copy that again. Okay. So you can see some value is there, and automatically you see tensor is given. 4 point something came. So that is the value of this variable y. Now if you try to understand how this 4 point value came, we can very easily explain it like this. We can see x tensor, what is this? Torch random 3 into 3 random tensor. So this is what the tensor look like. That's why we say it's array, but you can see it's a multi-dimensional. 3 into 3, you can see 3 rows and 3 columns. And random values. So these values might change. If I run this program again, 3 lines again, the total will be different. So that's why we say random. Random. And then you can see line 3, y torch sum. Apply. So the output is sum of all of those things. 3, 2, 1 plus this 4, 9, likewise. It still add up. Add that to all the things, then you can see the calculation is there. So it's adding up all the things, ultimately the value is given. So that is how this particular small line of coding, small code line is going to work. I hope you got an idea about what is a tensor is, because as soon as you define this coding in the Torch module, we are calling a function within the Torch module. And it's a random function 3 into 3. It defines a tensor. So tensor is nothing much a multi-dimensional array like this. So going forward, I am not going to use the word array. Now you know what is a tensor. It's a multi-dimensional value representation with rows and columns. But yeah, there can be more complex tensors upcoming, but for the time being, let's get the basics like that, multidimensional arrays. I hope you got the idea, and again I think we can try another exercise, another small practical here. So I have given the tensor similarities. We can see the arrays, right? Arrays and tensors, we have similarities. And again differences, we can see the differences. Tensor, underlying data structure. In a tensor, tensors are much complex than arrays and have more, you can see, sophisticated underlying data structure. They are backed by the memory, you can see, of memory accelerators like CPU, TPUs also there. Right? Tensor, TPU stand for tensor processing and GPU stand for rapid processing. So we will try to understand TPU also later. Is from Google, TPU is from Google, because Google is directly using TensorFlow, we know that. And these tensors specifically support these processing environments, TPU, specific chips designed for tensor processing. So that is with tensors. Arrays, you don't have such thing, enabling faster computations. We can see TPUs or fast tensor processing units, TPU, tensor processing units, are application specific to integrated circuit. That's what it says. Are application specific integrated circuits for specific faster calculation designed by Google. You can see, you can read it and see, for acceleration machine learning, acceleration by machine learning workloads. There are custom hardware chips. You can see the explanation. So TPUs for tensors. That's what there are major differences. We cannot actually compare arrays and tensors. Tensors are specific for ML, and so that's why there's a big difference. So this is because why we say arrays, because that's the term that we are most of our familiar. Okay, we got to know what is that, and we can try out another small kind of a program, model linear, importing specific submodules. Okay, Python import torch and then better try it on next video. Okay, thanks.